like a property that works. So do you discover it or do you create it? I think you discovered that this always works.
It always exists. If you invent it, you're making it up. It already exists. You're just figuring it out.
Like it's a truth that you are uncovering. But math, you can create your own math too, but we can't go down that road. You can create your own rule for math and decide that.
Why can't we just do that here and tell the AP graders that that's what we did?
If you can prove it, if you can create your own math to solve this and prove it mathematically, they would give you credit. But,
So you can't just make it.
yeah, it has to be
How do you
logically
create
sound.
your own math without using, like you? Never mind.
We can't go down this road right now. Maybe it's a conversation we can have later. All right.
I looked up just to finish the discussion. It says it was discovered in 1694, published in 1696.
Good to know. Use the word discovered. Depends on how far you think back. Yeah. So, if you think about, the grand scheme of human life, pretty recent. If you think about your life, not very recent. Okay, so this particular problem is another one that we can do without L'Hopital's rule. So for this problem, what would we use if we had the limit as x approaches infinity of 2x minus 7 over 3x squared minus 9? No HCC. This one is bigger on bottom, right? And so we would get 0. But perhaps you find yourself on the exam and you can't remember anything about limits except for L'Hopital's rule. L'Hopital's rule would still work here. You could do the limit as x approaches infinity of 2x minus 7. If I plug in infinity to that, what will I get? Infinity. And then limit as x approaches infinity of 3x squared minus 9. That would also give you infinity. So this time you're getting infinity over infinity, which is still an indeterminate form. So by L'Hopital's rule, no, as long as it's recognizable as L'Hopital's rule. Hospital is the correct spelling of it. So yes, you can put hospital if you
Do
want.
we have to put the
You're probably gonna need I would put the L.
so we can have the hospital.
Hospital has an S.
Yeah, that is all. There's alternate spellings for this. So some textbooks do use the S. I think our textbook does not, but some of the stuff that AP puts out does. So I'm not sure. But yeah, they won't be picky on that. Neither will I, as long as you're close enough. So we could say that the limit as x approaches infinity of 2x minus 7 over 3x squared minus 9 would still be equal to the limit as x approaches infinity of 2 over 6x, which still you're pretty much using Bobo-Botno, but you can see a little bit more easily here. The number on the bottom gets bigger and bigger and bigger, and this approaches 0 for that. So I wouldn't suggest using L'Hopital's rule on this problem, but it does work if you can't remember anything else. So this actually works for a lot of the limits that I taught you before. So if you forgot how to do them any other way, this will work for that. I am going to do number 3. I think so. Okay. So for number 3, if it's multiple choice, it doesn't matter. If it's free response, you would have to put the limit as x approaches 0 of the top and the limit as x approaches 0 of the bottom. Another option, I said I was going to do this, but I did not. If you plug in 0 here, you get square root of 25 minus 0 minus 5. That's going to give you 0 on the top. Clearly, you get 0 on the bottom. So it is acceptable to say is of the indeterminate form 0 over 0 instead of doing those limits separately. So that, although you do really want to plug in and check, because sometimes it's not and you can't use L'Hopital's rule. So you can state this instead, and then we could say that this is going to equal the limit as x approaches 0. We would have to take the derivative here, which is probably better to think of that as 25 minus x squared to the 1/2 minus 5. So we would have to do 1/2 times 25 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. And then the derivative of that minus 5 on the end is just 0. So you have to use a chain rule on that problem. And then what's the derivative of the bottom? 1. Okay, so this would be, really, the bottom doesn't really matter here. Limit as x approaches 0 of that 1/2 and the negative 2 cancel each other out, but the negative will still be there. So I would do this. I'd leave the negative x on top. I'd move the 25 minus x squared back down to the bottom and put it under a square root. And so now if we plug in, we would get negative 0 over the square root of 25 minus 0 squared, which would give us 0 over 5. And what is 0 divided by 5? 0. So you get 0 as your answer. Again, we can do that with the reciprocals there, or the conjugates, multiplying by the conjugate there. That one we already know how to do without L'Hopital's rule. So you don't have to use L'Hopital's rule in that problem, but you could. 4 is an example of one where at least I do not know how to do that problem without using L'Hopital's rule, because I could definitely factor the bottom of that, but I can't factor the top. I don't know how. There might be a way, but I am not aware of it. So in this, the limit of the top is going to be 1 to the 11th power minus 1, which will give you 0. And the limit as x approaches 1 of the bottom is going to be 1 to the 4th minus 1, which is 0. So you're getting 0 over 0 here. So by L'Hopital's rule, then we can say that this limit, and I'm doing all of these problems like it's a free response question. If it's multiple choice, I wouldn't necessarily state all this stuff at the beginning. And I also probably wouldn't write that over again if it was multiple choice. So we just need to take the derivative of the top and the bottom, and we will get 11x to the 10th. On the top, we will get 4x to the third on the bottom. And we can plug in 1, so we'll get 11 times 1 to the 10th over 4 times 1 to the third, and that will give us 11 over 4. Okay, questions? All right, let's keep going. Okay, so I've got a few more good examples of ones where you have to use L'Hopital's rule because we don't know any other methods that would work for this. Actually, that's not entirely true. We could do 5 without L'Hopital's rule. What's 5 going to be? It does not have an asymptote. What would its limit be? It's going to be positive infinity for that, because e to the x it like grows faster than x to any power whenever you get to really, really, really large numbers. So so this one is sort of like bigger on the top because e to the x is going to grow faster than anything else. But maybe you have forgotten that. Here comes L'Hopital's rule to save the day. Because, to speed ourselves along, let's, e to the infinity is infinity. Infinity to the third power is infinity. We're getting infinity over infinity here. If it was free response, you would definitely need to state that. But if I just go ahead and start taking my limits, what is the limit of e to the x? Oh, not limit. Derivative of e to the x? E to the x. What is the derivative of x to the third? 3x squared. Now, still going to get infinity over infinity here. But so I could do L'Hopital's rule again, right? And so I would get the limit as x approaches infinity. What's the derivative of e to the x? Still e to the x. Now we're getting 6x. If we plug in infinity, we still get infinity over infinity. But if we do this one more time, e to the x over 6, now if we plug in infinity, we're going to get infinity in the top, but it's just divided by 6. So what is infinity divided by 6? Still infinity. Okay, let's look at a trig problem. If I plug in 0, sine of 0, what is the sine of 0? Is 0. What is tangent of 0? It's also 0 because it's sine over cosine, which would be 0 over 1 at that point, right? So if you were doing free response, you would need to state that. But let's pretend it's not. So if we take our derivative, we get the limit as x approaches 0 of, what is the derivative of sine? Cosine of 5x, but what do I have to do extra here? Multiply by the derivative of the inside, which is going to be 5. I'm going to go ahead and write that out front. What is the derivative of tangent? Secant squared. So we get secant squared of 9x. But again, a chain rule here. So you got to multiply by 9. And then you got to hope whenever you plug this in that it gives you something you can work with. So if we do 5 cosine of 5 times 0 over 9 secant. I'm going to write like this. 9 secant 9 times 0. I'm going to put the square out here because having square in the other places confuses me a little bit. So what is cosine of 0? In the unit circle, right here, it is your x coordinate, so it is 1. And, well, secant. Secant is 1 over cosine. What did we just say cosine of 0 was? 1. So it's 1 over 1, which is still 1. So secant is 1 also. And you got to square it. It stays 1. So we get 5/9 for that. Okay, questions? Okay, this one is one that we could have done before, but I would almost bet money that we have forgotten how to do it. You might remember how to do that without L'Hopital's. You can like split it up because there was a rule that said the limit as x approaches 0 of sine x over x was 1. Right? It was like a 1 minus cosine that was 0. So you would have 1 times the limit of cosine. I think you get 1 for the answer here. But I'll be honest, sometimes I forget that rule. And I've done it for a while. So most kids usually forget that. L'Hopital's rule works here as well. If you plug in, you get 0 over 0. So if we do the limit as x approaches 0 of, what are we going to use for the numerator? Product rule. So we would have to do sine of x times the derivative of cosine, which is negative sine of x, put that negative out front, plus cosine of x times the derivative of sine, which is cosine of x. And then the reason this works so well, what's the derivative of the x in the bottom? 1. There. So I've got the limit as x approaches 0 of negative sine squared x plus cosine squared x over 1. And if you plug in 0, you're doing negative sine squared 0 plus cosine squared 0 of, it's not really necessary for me to keep writing that over 1 right there. What is sine of 0? 0, and then we're going to square it, which is still 0. And then what's cosine of 0? 1. We're going to square it, which is still 1, and you'll get 1 as your answer. One thing I like about L'Hopital's rule is that it works for so many different types of limits that we had to have separate rules for before. It's not always the quickest way to do the problem, but you don't have to remember as many things to use it. You just have to remember this one single rule. So a lot of kids use it even when they don't have to for these. Here is a good example of something they like to give you where you have to use L'Hopital's rule. So the graph below shows the graph of f of x. The line tangent to f at x equals 0 is also shown. We are supposed to find the limit as x approaches 0 of 2f of x e to the x plus 4 over 3x squared minus 3x. That is a crazy limit right there, right? And so let me actually change. I'm going to change my tangent line to a different, oh, let me unlock it. Change that tangent line to a different color. Let's make it red so it shows up well. So for this, I need to, this is probably more like a response question. So I want to do the limit. Plus, I don't really know if this is 0 over 0. I need to think about that. So I'm going to do the limit as x approaches 0 of 2f of x e to the x plus 4, which we're going to plug in 0 for all of our x's. So we'll have 2f of 0 e to the 0 plus 4. And f of 0, we're going to look at that blue dot right there, and it's just your y coordinate, which is 2 times negative 2, right? So it's just your y coordinate right there at 0. And then what is e to the 0? 1. And when you do negative 2 times 2, you'll get negative 4 plus 4 is going to give you 0. And the bottom is much easier to see that that does equal 0. In fact, like, it's okay to just go ahead and say that equals 0 without showing that you plugged it in, because 3 times 0 minus 3 times 0 is going to be 0. There. So we could say by L'Hopital's rule, we can take the limit of the top, the derivative of the top and the bottom. I got 2f of x e to the x plus 4. What am I going to have to use to take that derivative? That's a product rule. So I'm going to have 2f of x times the derivative of e to the x. What is the derivative of e to the x? E to the x plus e to the x times the derivative of 2f of x. What is that? 2f prime of x there. And then you do have to take the derivative of that 4 right there, but what is it? It's 0, so it goes away. All over 6x minus 3. And so at this point, let me stop for a second, make sure. All right, here. Okay, at this point, you're plugging in 0 for all of your x's. So you'll get 2f of 0, e to the 0 plus e to the 0 times 2f prime of 0 over 6 times 0 minus 3. We already found f of 0 once. What was it? It is negative 2. E to the 0 is just 1. What is f prime of 0? It's not 0. It is negative 1. How do you know that, Webb? It is the slope of that tangent line, because your derivative is going to be your slope of the tangent line, and this is the tangent line at 0, so the slope of that line is negative 1. They could not give you this problem without showing you that tangent line and making it one where you could actually like count the value there. And so if this was free response, you could just stop here because you have now plugged everything in. But let's go ahead and get an answer for some closure here. We'll get negative 6 over negative 3, which will give us 2 for the final answer. They really like these types of problems on the exam. All right, I think we got time for our last one here. Similar thing here, but they gave us a table instead. So first of all, you want to see that you do get 0 over 0. So our limit as x approaches negative 1 of 2x f of x minus 5g of x would be 2 times negative 1 times f of negative 1 minus 5g of negative 1. What is, so you got negative 2, what is f of negative 1? is 5, because your x coordinate is over here. So all these are f of negative 1, f prime of negative 1, g of negative 1, g prime of negative 1. And they'll have minus 5 g of negative 1. What is that? Negative 2. And that would give you 0. And the bottom, that one also gives you 0. So by L'Hopital's rule, we need a derivative of the top and of the bottom. The bottom's easy because the derivative of that bottom is just 1. But the top is not so simple. We'd have 2x times the derivative of f of x, which would be f prime of x, plus f of x times the derivative of 2x, which would be 2, minus the derivative of 5g of x, which is 5g prime of x. You do not have to use a product rule on that part because 5 doesn't have a variable with it. And on the bottom, we'll just get 1. And so you're plugging in negative 1. And we got negative 2 times f of negative 1 is 5. No, f prime. That's 1. Plus 5 times 2 minus 5 times g prime of negative 1 is 4. So we would get negative 2 plus 10 minus 20. And I believe that will give us negative 12 for our answer there. This worksheet is like a circuit worksheet. How about I say this? There are 14. You gotta get at least to the 7th one. Try to get at least to the 7th one. Further is even better, but try to get at least to the 7th one.